Okay. So remember the ones we did last time? So we looked at adapter, right?
Yeah.
Yeah. So yeah, this is what we did, so the adapter. So just to quickly recap, so we can use an extension function like this, yeah, and then we can adapt to things, So adapter is, as the name says, we can adapt the system to another. Yeah. So simply, if you ever get into a situation like that, we can adapt to things. So we can just remember that. I mean, you can use an extension function to adapt to things. Yeah. Right. And then yeah. So now yeah. So today we can move to bridging design pattern. Right. Um, so this is a quite a nice one, and this is actually the dependency injection. The framework dependency injection is actually using the bridge framework. Sorry, bridge design pattern. So because of when I say dependency injection, you can use the dependency injection to work with any legacy code and also to avoid inheritance um, problems and things like that, right? So this is again bringing in the design pattern as from the dependency injection framework. So you'll see, how the dependency injection or the bridging will help us here. And also because of that in place, as the other design patterns also help us, to keep the system flat, like, very composite units as, so this would also, solve that problem. So all these design patterns are kind of solving many similar problems, but the pattern itself, itself is used in a different way. Yeah. So that's
Can you just explain the word flat a minute, please? Sorry.
yeah. So remember that, when we saw the decorator or something, and we were seeing a lot of class hierarchies, yeah, and then things were tightly getting coupled.
Mhm.
So this will also help us, keep everything flat as in, single units and no extensions,
Mhm.
yeah, no uh, uh, polymorphism as much as we can, yeah.
Okay.
Yeah, so it's always easier to keep a single unit, which will always do the same thing, and we will call that thing. If you want that thing to be doing that certain thing for us, so something like calculate age. So that class will be always calculating age. Yeah,
Mhm.
and then if you ever want to calculate age, we just call that. So we will not have any messy hierarchy with that, so that's how things go wrong, so because if you look at the software we design, every single thing should be doing something, right? So if you keep them as single unit, it's easier to plug in and plug out in the system, right? So if you have the moment we start having class hierarchies, like base class, and then that has children, and that children has many children, and things like that, nesting hierarchies and all that, we'll get into a bit messy. It's harder to maintain.
Mhm.
So that's why they say composition is always better than polymorphism. Polymorphism.
Mhm.
Yeah. So composition mean composite objects, keep them separate, keep them as single unit.
Can we just run through polymorphism again while we're here, just because you mentioned the word?
Yeah, yeah, let's get the wiki then. Um, poly, oh, I don't even know how to spell that thing, man. There you go. Polymorphism. Polymorphism is a Greek word, means many shaped. Okay, what does that mean in the Wikipedia? Programming languages theory type theory. Polymorphism is the provision of a single interface to single interface to entities of different types, or the use of single symbol to represent multiple different types. The concept is borrowed from principal biology, where an organism or species can have many different types. So it's simply talking about, how many different types you can have from one single interface or a base, you know. Uh,
Yeah.
and then there are different types of polymorphisms as well. Pragmatic polymorphism,
Mm.
subtyping, raw polymorphism. There are different types. Yeah.
Okay, yeah.
Uh,
No, I meant when I said polymorphism, I just meant the Java definition. That was it.
yeah. That's what it is. This is kind of the Sudoku code, for polymorphism. This is how the Java is also doing it. So
Okay.
yeah. So if you want to say that in Java world, I mean, it's something that, I mean, if you want to have a parent class, and if you want something to extend it so that the children can inherit the behavior from the parent class,
That's
that's what
right.
we are doing it as
Yeah.
polymorphism here.
Yeah.
So a relationship in between parent and child by extending the parent,
Yeah.
for inheritance of the behavior from the parent. That's polymorphism. Yeah.
Yeah. Thanks. I just needed to jog my memory. Thanks a lot.
Yeah. So these days, I mean, we've seen in the past, if we have, classes have relationships between them, it's harder to break them out, So why do I need a child which inherits behavior from parent? And then if that child is doing something extra, the parent can do, as well as uh, some extra things it's doing. Why don't we break those two into two different things? As child do whatever the child needs to do, and the parent needs to do just whatever that thing needs to do. Because in the end, everything we write as classes should just do one thing, right?
Yeah.
Yeah. So that's why it's not needed. I mean, class hierarchies are not much needed always.
Okay.
Or even if you want to have it, just keep a very simple relationship, I mean, when it's needed, I mean, if it's not going to really mess up by having so many classes becoming children to a parent,
Mm.
that's when the system will get messy, and it's harder to maintain, Yeah, cool. So this would also solve the problem, if you start getting many class hierarchies. So let's have a look at an example. Let's create something. Mm. Okay, let's start working then. Good. Right. Imagine we want to build some robots, yeah, because this is the example I saw it, in the book.
Hmm.
Imagine we want to build some robots, and say, yeah. So immediately, if you want to create an object and that type, we tend to create an interface, right, to define the object we want to build, or to define. Yeah. So robot, and then this thing, let's say, I mean, what a robot can do. Robot can walk. No? Let's call this as, I mean, uh,
Yeah.
function walk, just to keep it simple. So you can walk, and if you want to walk, we can say from X to Y or something, in our coordinates, right? Yeah. And then similar, he can attack if it's a game space, invader game or something like that we're building. You can
Hmm.
attack at certain positions. So let's call them as, in those certain positions in the coordinates as well. Yeah, cool. So we've just defined two behaviors for a robot, right? And I'm going to create the robots now. So what we do, class, let's say that, I mean, we want to build these robots for space, and, to be residential, so some robots will work in the houses, and some can go to space, yeah, and do something. So let's say space robot. I'm just making up these
Yeah.
the words, right? The names. Um, robot. But in the book, it's a different example, but that's a bit complication. I mean, it's just complicating, So this is
Yeah.
the
You're making it simpler for us. Yeah, I understand.
okay. Yeah, thanks. Right. Yeah. So I'm reading the book, and I don't know whether I told you or not. So I'm reading this Kotlin design pattern book by Alexis Sergey. He's at Depop at the moment, where I used to work, and I know him as well. And he has written this book, which is a very good book for Kotlin design patterns. Jason, I've
Yeah.
it before.
Mm.
So this is where I'm picking up all these examples, and I'm coming with So, but the examples are quite sometimes complex, so I change them according to
Okay.
I think of. So all if you look at a book, the things we are seeing are not exactly the same, but the concept's the same. But I'm picking different examples to put them in code. Yeah, he has also done the same. So, but explaining all these design patterns, which is well covered. And because there is no book at the moment, for Kotlin to show design patterns. There are a hell of a lot of books, for Java, but not for Kotlin. So thanks to Sergey, Alexei, sorry, not Sergey, somebody else, Alexei Soshin. Alex.
Oh,
Yeah,
okay.
he's in London. He's in one of these laundries, so you might meet him, so he comes along for these laundries and all that. And
Okay, good.
yeah, JetBrain, this and IntelliJ guys, JetBrain. JetBrain is the one who builds these tools, right? The IntelliJ and Android Studio, they own it, and they work with Google, and they are the people who invented Kotlin as well. So they now, work with Google because of Kotlin is from JetBrains. Yeah.
Mm-hmm.
So thinking of how big JetBrain is, and these JetBrain guys promote Alex's book, Kotlin Design Pattern, because this is the
Okay.
first design pattern book which has come out for Kotlin. So JetBrain promote his book, and in some of the JetBrain's YouTube channels, he's been interviewed, and yeah, so it's quite.
What's his name again?
Alexis Oshin.
Okay.
Yeah, send you the details if you want. And I bought this book, and it's a really nice book. And this is the book, and anyone can use to learn Kotlin as well.
Is it totally different from the Java version of design patterns?
No, see, Java design pattern is design pattern, right? All the patterns are the same, but we are now writing in Kotlin. Yeah.
Oh,
If you buy
okay.
a book, I still have a book which I bought a long time back, which was for Java, Head's first Java design patterns, which is also a good book, and that covers all the design patterns. These are the design patterns, but written in Java though. But if you write the same design pattern in Kotlin, you can make it more concise, and you can bring some cool features which Kotlin promotes to
Yeah.
put into the design pattern, so the code will become much easier to work with. So we can see the Kotlin features come and help in these design patterns as well. When you do this. So yeah, that's what he has shown, Alexei. So a big thanks to him actually. So not many people have written Kotlin design patterns. Yeah, cool. So let's implement these methods. Yeah. So he needs to walk and he needs to attack. Yeah, at certain points. So yeah, okay, yeah. So we don't want to worry too much of it. How it's going to walk and how it's going to attack and all that. But we just create these objects. Yeah. So let's say I'm going to build another class, another object, to be residential. Yeah. So this is going to work. Oh, this is going to be in. With me, guys.
Yeah, yeah, he's going to be in the house.
Yeah, yeah. Soon coming, right? Cool. Elon Musk is working on this. Yeah, cool.
Did you not see Humans a few years back on Channel 4?
Humans, a program.
Yeah, yeah, it was a series about residential robots, and they went bad
Okay. Is it
in
real
London.
or some document? Is it real documentary?
No, not a documentary. This was a program. I think it was done by BBC Two or Channel 4, but it was really
Okay.
good.
Is
But if
it?
you just type in humans,
Yeah.
you'll the budget was really big, and
Ah,
basically the actors
yeah.
were humanoids, but they were robots in the program.
Okay. Cool. I'll check it out. Right. Right. So we have created two different types of objects here. Robots, but they're all robots. Now say, I want to even split this further. So I have a space robot, and now I'm going to create some different types of space robots. Yeah. So let's see how can I do that. So yeah. So mostly we will make this class open because we have a space robot, and now these are different types of space robots. So we can open this, And then I would say class space. So Mars robots, yeah, Mars robots can be a space robot. So I will extend this. So I could think, this is my child, this is the parent. Yeah. So this is, of course, I'm in a class. So I can now override any of the ones I want, right? So the Mars ones, can walk differently to any other space robot. So we define that here. So we can override it. Yeah. Yeah. You with me?
Yep.
Yeah. Okay, cool. And then let's create some more. Mars. What else? Neptune or something? Neptune robot now.
Yeah. Different planet robot.
Yeah, different planet. Different planet, different robots. Yeah. I can do the same as well. Yeah. Agree? Of course. They're all going to have different ways of walking. I'm not implementing anything, but I'm showing that. I mean, if I override the walk, then that will be different to this one, and both of them will walk differently to whatever the implementation we will have for a default space robot, right? Cool.
Yeah.
Right. Now, suddenly somebody comes and say, I want to let them speak. That needs to speak with the language or something. See how everything breaks? Boom.
Okay.
Our design is breaking everywhere, right? Right. So this is the problem of, having connections and, how do I say it? I mean, having relationships between classes, right? So, right. So what we can do is, in order for us to, keep the way we are going, we need to think, what other way we can see these can be derived. So if you look at the classes, the walk and attack are the behaviors of all robots, right? Yeah. And they are the ones who change in the definition of a robot, because that's our definition for a robot. Anyone can come and add new things here, right? So if you see that, and then we need to think as, what the bridging would do do it for us here. So the bridging is telling the bridging design pattern. If you think that, if you want to bring in bridging here, we can think of as, why don't we then create the classes for these as well and pass them as dependencies or bridge them into those. Yeah. So immediately, if we get into a problem like, a robot, every single robot would do all these things defined here, then we can see these as um, um, define an interface and provide their own implementation, which will eventually become the dependencies for the robots to do something with. So I'll show you what we can do is we can further create an interface called, no, to walk, we can choose a leg, right? Because eventually what this is going to do is, it needs to walk. But the dependency for that is, it needs to walk with a leg, isn't it? So we can define a leg, and we can then say it knows how to walk. You see what I mean? So we split this into its own thing, right? And then attack could be another one, weapon or something. So you need, for us to attack, we need a weapon. Is it?
Yeah.
Yeah. And then we say, now you say you know how to attack. And immediately now we can then say, this is our space robot, right? Yeah. Immediately then we can say the space robot is going to have the dependency on these. So walk, sorry, leg as the dependency on leg, and weapon as weapon, right? So now we have them as dependencies. So if you now want to walk, we can call these with X and Y. And then if you want to attack, we call the weapon. Yeah. So if somebody comes and add another one, then we'll simply pass it as a dependency here, you know. Yeah. And then the same goes to these as well. So I was just showing, and I mean, how can you do this? So we will bridge them through other dependencies. So here we're just passing the dependencies. So instead of, I mean, we need to go and implement them every single place. We provide the dependencies, and that will take care of, I mean, how these should be behaving. Yeah. So simply, anywhere we see, the behaviors can be broken into their own dependencies, we should be doing this, and provide the dependencies to the class to work with. Rather than it needs to know how to implement them. So the walk is implemented through another class itself, a leg. So I can provide the leg here, right? So I can now say class fast leg or something. So this will have its own implementation to walk. So here I'll provide the actual implementation, how this is going to walk. And whenever I need to create whenever I don't need these flavors now. I can comment these out. So I can simply create a mouse robot by creating it with the dependencies it need. So if I have a main function and I want to now create the mouse robot, I can then say, I know the space robot is the space robot. So, but the mouse robot will be having its dependencies with, because at here, when we had that, the extensions, we were simply overriding how the walk and how the walk was going to be different, right? So we provide the different legs here to be able to walk in different way. If the mouse robot is going to walk in a different way to the other space robots we create. So here I can probably say fast leg. And we don't have a weapon. Let's create a weapon as well. A gun or something, or tank or something. So this is how this is going to attack. So I can then, give in a gun or tank. So if I want to create another one, a Neptune one or something, Neptune robot, then probably I'll change the leg to be a different one and the tank another one, another weapon. You see how the things are more flattened now, rather than start creating the hierarchies. So I provide the different behaviors to create different type of objects. So this space robot is the one which is going to have different types, as we saw by having this extension. But now we see they are all going to just, provide different behaviors. So we push them into different interfaces to provide their own implementations and provided them as dependencies here. So if ever somebody wants to create a space robot in different shapes, they will have to pass in these dependencies, which are the only two things would differ here. You understand? This is dependency injection, by the way, guys.
Okay.
Yeah. Don't think as in, seeing the problem and then, how to get into this, but this is natural though. We will never start creating a lot of these like that. Whenever you see, you can create a weapon and you can create a leg, which are the ones which will bring in these behaviors. You will go down that way anyway. No one does this. But in case if you see anyone does it, I mean, you'll be able to spot it and say, hey, look, I mean, why don't we push these into their own interfaces, as this is what that space robot needs. So provide them as dependencies. You know, this is the dependency injection though. So if you use Dagger, we will not even create these. We will have, yeah, we will use Dagger to provide the actual implementations of the, you know, weapon here as, you know, I mean, it's a tank and leg as a fast leg or something. Yeah. Any questions? Guys? Charlie?
No, no.
Hmm.
Everything good.
Um,
You're not happy.
yeah, I got I got a bit lost when you put the functions in the as parameters.
Here.
No, function call.
Where? Line number?
Line number 44, I think.
Yeah.
Yeah.
Oh, yeah. So I'm simply creating different space robots, right? Because I haven't, now we don't even need to have this as an open class. So I'm creating concrete implementations of them. So I have a space robot, and the definition is it's a robot. So they need to know how to walk and how to attack, because the definition of a robot is walk and attack. Yeah, because this is our definition. And I've created a space robot, which will be a robot. So the robot should walk and attack. And in order for it to walk and attack, I need to implement those. Yeah. So rather implementing it here, I have pushed the actual implementation into different places. So I've created further interfaces. One is weapon, because of the actual implementation of attack should come from another place, which is the weapon, right? So if you have a weapon, you then can say, oh, yeah, that's the one which will know how to attack. And if you have a leg, that's the one which will know how to walk. So I have extracted the implementation of walk and attack in this class to separate classes. So walk will be done by a fast leg implementation of the leg. Yeah. So when I'm creating an instance of a space robot, and imagine if that's a Mars robot we're defining, and if the Mars robot can have a fast leg, I pass in that as the dependency. So this is the fast leg, which the leg I need to pass in as, you know, to create the space robot, because of the first dependency here, the dependency in this case, you know, the first construct argument is a leg and a weapon. Yeah. So that's why I'm passing in a leg and a weapon. And always define, I mean, when you have a class, and if you're thinking, I mean, they are different classes and they are the dependencies I need, then push them behind an interface. So this class wouldn't need to worry about, I mean, what the actual implementation as well. So what sort of leg this is using, it doesn't need to care. See, this space robot doesn't need to care what actual implementation of the leg is coming. That's when at the call site, when at the place we create this, that's when we decide, I mean, what sort of leg we want to pass in. But this class itself wouldn't need to worry about, I mean, the implementation of a leg or weapon. Whatever the leg passed in, I will call the walk on it, because I only care about, I mean, the walking as a robot. But using which leg, I don't care. That's why this is behind an interface, you see, and the weapon as well. So we don't care about those. So this is again easier to test as well. So if you ever want to test this class, now we don't need to worry about the actual implementation. We can provide our own implementation in the testing, because this is an interface, you see, like this. So now when we create the actual instance of the class, I can create it with actual implementation for the leg and the weapon. Simple as that. This is how the injections work. I mean,
right. This is manually doing dependency injection.
Exactly. Thanks for that word. Yeah, manual injection. Manual injection. We are manually injecting the dependencies here.
Right.
If you use Dagger, of course, I mean, you have a Dagger annotation saying provide, inject here, and provide the actual implementation in a component or module. Yeah, Dagger module. Things like that. Jared, do you use Dagger though? Have you used Dagger?
Sorry?
Do you use any injection, dependency injection framework?
No. Framework, sometimes we use, but row level we use that.
Right. Okay. Okay. Yeah. Yeah. Me and Jason are using Dagger, and now we're going to look at Hilt as well. So Hilt is quite famous in Android community. Google is pushing for it. Google is saying, and I mean, if you ever want to have an injection framework, use Hilt. Yeah, Dagger used to be famous, but now Hilt. Yeah. Oh, no. Why now? Yeah. Yeah, so that's bridging. Actually, this is the dependency injection, injection framework as well. So this is the dependency injection. So the dependency injection frameworks use the bridging design pattern. Yeah.
Right.
Cool. This is just easy as that. I mean, because yeah. So the main highlight is, I mean, if you ever see things can be provided as dependencies to a class, create them as dependencies. I mean, create them as the classes you can provide. Simple as that. Yeah. But can you see why the leg and the weapon have become the dependencies to the space robot? Why do we think? And I mean, those two, we need them as dependencies. Can somebody answer that? Yeah. Why did we want a leg and a weapon for a space robot?
Sorry, I don't know that answer.
Yeah. No. All I'm asking is, I think sometimes, I mean, the questions become complicated, but the question itself is posed by thought. Huh?
Question, can you ask? It's not clear. Questions.
Okay. So I'm asking, we define this class, right? Space robot.
Yeah.
And we had to put these in. So we said, we want a leg and a weapon as construct arguments here, right?
Yeah.
Why did we want a leg and a weapon? Why can't we not having any of those? What's the purpose of having these here? That's the question. So why did we want a leg and a weapon as dependencies? Because yeah,
yes, attributes.
Attributes.
Yeah.
What do you mean?
What do you mean? Walk and attack.
Yes, behaviors, right? These are the behaviors, no?
Yeah.
These are the class behaviors. No, not the attributes. These are the behaviors, no? It needs to, because a space robot is a robot. And if I say, it's a robot, it should walk and it should attack. And I said, if I ever want to walk, I will need another thing, another one, which will take care of the walking. Yeah?
Yeah.
Isn't it? Yeah. So that's why these have become dependencies, because we saw every class, otherwise every class was just, providing its own way of walking. So why don't we push every class common behavior into a dependency? If you all want to walk, provide your own implementation through an interface called leg. Simple as that, right? Yeah. So that's how, we identified the dependencies. If something becomes common in all classes that, we want to implement, push that through a dependency, push that through another class and provide it. Yeah. Cool. Should we go further or you want to dig a bit more? Jason?
Yeah, I ain't gonna lie. This bridge pattern is a little bit difficult for me to understand. I'm just trying to mull it round. Maybe we can go on, and afterwards I can see the video and go through it on my own.
Sure. Okay. Yeah, Charlie, what were you saying?
Within means session will be closed. this session.
Sorry.
We have 35 seconds to.
Ah,
This
for
will
this
be
to end. Oh, I see. Oh, I see. Uh-huh. Okay, when it stops, we'll start again. Yeah. Yeah. Okay. Where does it say 35 seconds? Less than a minute, it says.
There's countdown here.
Ah, okay, okay. All right. Uh-huh. All right. Yeah. Okay. So I'll also think